Okay, students, what comes next is another question, and let's talk about again solving question number 14. So you are given what, students? You are given 1 point where the line is going to pass through, and the point is 1 minus 2, 1. And you are supposed to now look for the equation of a line which is parallel to the given line and passing through the point 1 minus 2, 1. So let you follow me how I'm going to do. The solution runs like this. If two lines are parallel to each other, students, then their directing vectors are parallel too. So one is a scalar multiple of the other, students. So if one is scalar multiple of the other, we can directly take the directing vector of the other one as a directing vector for, you see, the line we are looking for. Simple. So the directing vector for the given line x equals minus 1 plus 2t, y equals 3t, and z equals minus 2 minus t is basically what? 2, 3, minus 1. Vector 2, 3, minus 1 is directly obtained from the coefficient of t, 2, 3, and minus 1. Now, students, what follows is the directing vector 2, 3, minus 1 can also be used to direct the intended line. Basically, I can also use a certain scalar multiple of this one, but later it will be simplified. So we can directly take this directing vector 2, 3 with components 2, 3, minus 1 for, you see, the line we are looking for. So using the parametric equation of the line, as I said earlier, we can determine what? The equation of the line parallel to the given line. We know that x equals x naught plus at plus y equals y naught plus bt, z equals z naught plus ct is the general parametric equation where a, b, c are components of directing vector, x naught, y naught, z naught are components of the point lying on the line. So as it has been given, you see, ABC is a vector with components 2, 3, minus 1, and the point x naught, y naught, z naught is already given. It's specified here, as you see, 1, minus 2, 1. So the next task is a matter of now plugging these values in their corresponding place above. Then the parametric equation is going to be x equals 1 plus 2t. What I did here is I just put in place of x naught I just used 1, and in place of t I used 2, so 1 plus 2a, 1 plus 2t, sorry, can come. Do the same for y. In place of y naught you can take minus 2, and here b is now 3, so minus 2 plus 3t, and do the same for z. You are having this. So this is a parametric equation of what? The given line. Now if you are interested to determine the symmetric forms, just solve for t. So in order to solve for t, for the first one, for instance, you can move 1 to the left and have x minus 1 over 2. And for the second, you can have y plus 2 over 3, move minus 2 to the left, divided by 3. And then for, you see, the last one, you can move 1 to the left and divide the whole by minus 1, z minus 1 over minus 1. So the symmetric equation of the line can be as you see. Now what comes next is question number 15. You are given arbitrary 2 points where the line can pass through. The question is to determine the symmetric and the parametric equation of the line. So first we have to determine, students, the directing vector. The directing vector can easily be obtained simply deducting what? 1 point from the other, you see? So this can be obtained simply deducting one from the other, the components of 1 point from the other. For example, you can deduct minus 2 and minus 1. So you can have minus 2 minus minus 1, as I wrote here. And also 1 minus minus 2 and minus 1 minus 3. So students, for the first one you have minus 1, and for the second 3, and this one minus 4. So guys, you can take the directing vector components to be minus 1, 3, minus 4. The reason behind this is because if these 2 points lie on the line, you see the vector made by these 2 points is also lying on the line. So this vector can be parallel, or can be directing what? Can direct what? The given line. So we can consider like that. So our ABC now are minus 1, 3, and minus 4. So using the parametric equation of the line, one can determine what? The equation of the line. This is our governing what? Formula. So we are free to take A minus 1, B 3, and C minus 4, as I explained. c minus 4 as I explained here, and x naught, y naught, z naught, take an arbitrary point on the line. So you are free to take either this one or this as you wish. Whatever point you may use, you are going to obtain same equation. Okay, so substituting these values in their corresponding places above, you can obtain the parametric equation as you see. X is minus 1 minus t, and y is minus 2 plus 3t, z is 3 minus 4t. So now students, if you want to solve for t, you come across with a symmetric equation. So its symmetric equation is going to be like this. Move minus 1 to the left, it's going to be x plus 1. As you see, if you move minus 1 to the left, x plus 1, and divide by minus 1, t comes. So everything is solved for t here. Move again minus 2 to the left, y plus 2, and divide by 3. Move this 3 to the left again, z minus 3, and divide that by minus 4. So this is going to be the symmetric equation. So whatever points you may get as x, y, z, you see, if it can satisfy this, it is a point lying on the line, you see. If your numbers x, y, z can't satisfy this equation, the point you are considering is not lying on the line. So in such a way you can identify whether a given point is lying on the line or not. Now what comes next is question number 16. Here you are given a plane, students. 2x minus y plus z plus 2 equals 0. This is the equation of the plane. And you are given also a line, symmetric equation of a line. X minus 1 over 2 equals 1 minus y equals z plus 1 over what? Minus 2. So whenever a line and a plane are given to us, there are three possibilities. Either the line may lie on the plane, or the line may never intersect the plane, or there may be a situation where the line may intersect the plane at one point. In the case of this, the line will intersect the plane at one point. Okay, the reason for this is because the directing vector of the line is not perpendicular to the normal vector of the plane. If it is perpendicular, it will be parallel, students. Anyway, or it may also lie on the line. It may also lie on the line. Okay, the line may lie on the plane. Okay. Now proceeding to the solution, students. Now it's known that the given equation is the symmetric equation of the line. You see. So we can adjust this to be t. X minus 1 over 2 equals 1 minus y equals z plus 1 over minus 2 equals t. So we can assign this to be t as we did before. So when we solve this, we can obtain this one, look, students. So when we take each fraction, x minus 1 over 2 is equal to t. Now multiple by 2. So x minus 1 equals 2t, alright? 2t can come. Here, 1 minus y equals t can follow. And finally, z plus 1 equals minus 2t can come. Now, students, let's now write these three in terms of x, y, z. So in doing so, we can obtain this. Minus 1 can move to the right, and 1 plus 2t. Here move minus y to the right and bring t to the left, 1 minus t. And move this one to the right, minus 1 minus 2t. Now students, like you have been told that, you see, the line intersects the plane at one point. So what we need to do is, at the point of intersection, you see, the point must satisfy, you see, the point of intersection must satisfy not only the line, but also the plane, because it is a common point, it is an intersection point. So let's substitute the obtained x, y, z where in the equation of the plane. So substituting this in the equation of the plane to x minus y plus z plus 2, we can have this one, student, because x is 1 plus 2t, so we can directly put that there in x. And y is 1 minus t, so have minus in front, and then 1 minus t directly can be substituted, and in place of z you can take minus 1 minus 2t plus 2 equals 0 can fall. So students, as you see, the sum of this makes 3t plus 2, student, 3t plus 2. So when you solve for t, you are going to have minus 2 over 3. Once you obtain minus 2 over 3, what you need to do is you have to substitute the obtained minus 2 over 3 there in x, y, and z expression. Okay, so when you substitute that, you will obtain, students, when you substitute minus 2 over 3 there in x, in x here, you will obtain this to be you will obtain this to be a certain number. So have that one, and when you substitute again that, look, when just take minus 2 over 3 and substitute that here, and again take minus 2 over 3 and substitute here, and here take minus 2 over 3 and substitute here. So you can now obtain the corresponding point, student, the corresponding point. So substituting that, one can obtain this. So the point of intersection is going to be negative 1 over 3, 5 over 3, 1 over 3. So do you confirm that the obtained answer is right or not, students? What you need to do is you have to substitute x minus 1 over 3, y 5 over 3, z 1 over 3 in both the line and the plane equation. It must satisfy. And you can verify that by your own. This is how it can be done.